The Black 1976 model, generally used for future contracts, valuation of swaptions, is a variant of the Black Scholes model. In this video clip, I'm going to try just link the relationship between the two and how one model is in fact just an extension of the other. So just to take an example, I'm going to look at a currency option. Currency option is like any other type of option, including an option on a stock. So this is the Black Scholes model. Instead of E negative QT, we have here the E negative R subscript F, which denotes the return on the foreign asset. Okay, so basically let's just have a look at an example. Calculate the value of an 8-month European put option on a currency with a strike price of 0.5. Current exchange rate is 0.52. Volatility of exchange rate 12%. Domestic risk-free interest rate 4%. Foreign risk-free interest rate 8%. We can take those parameter values and summarize as follows. So 8 months is this T equal to 0.6667. Okay, and if we work through the detail D1, D2, and then applying the Black Scholes formula, we get a value of 0.0162. Okay, so let's just take this example for a moment and plug into some workings that I already have, and I'll just paste in the detail just to give us an overview of what's going on. Okay, and redimension this a little bit and pull out and format, and we'll fill with something. Okay, so we have values of 0.52. The exercise is 0.5. The risk-free rate in the local currency is 4%. In the foreign currency, RF, so I can change this to RF, is equal to 8%. So higher rate of return in the foreign currency. T is equal to 8 months, if I remember correctly. So it's an 8-month. Okay, so we'll go back in, and we can just write this as being equal to 8 divided by 12. And the volatility here is equal to 12%. Okay, and we get D1, D2, and D1 and D2, and negative D1 and negative D2. And we find the value of the put option, both using VBA and just the formulas is worked out here, the manual cell referencing. We find that the value of the put is consistent with the value that we have here. Okay, and we also discovered that same values for D1 and D2. Okay, so if we were to use, again, the same question, same basic options problem could also be addressed using the Black model. Now here I've used put-call parity just to infer the value of the call once I know the value of the put. But what I'm trying to discover here is how would we apply the Black model to address the same problem. Okay, so again, same parameter inputs. However, we don't have F. We only have S. So if we go back to the initial values here, paste. If we want to determine the value of F, given that we know the spot price, okay, we could apply this formula here. So let's have a look at that. So for the spot, it's equal to EXP open bracket, and we have R minus RF multiplied by the time period, and the time period is 8 months, so 8 over 12. Okay, so that all goes in brackets, and then that in turn gets multiplied by S. So SE, this no arbitrage relationship exists with currency. The spot price of the currency is equal to the futures, but we must take account of the differential and interest rates. Okay, so we kind of have embedded here is also a no arbitrage relationship and also an interest rate parity relationship from international finance. Okay, so we must multiply here by S. And we get a value of 0.50632, which is consistent with what we have here. Okay, so I'll just remove that for a second, go back in, and then get the breakdown of the parameter values. So we'll take this, where I have my workings, come back into the spreadsheet just to verify the values are consistent, redimension this a little bit, and maybe fill out. Okay, so format and a little bit of white in the background. Okay, so we need to get the value of the call and the put. Okay, so I have to fill in the same X, so these values are the same in fact. Okay, so X are, okay, better be careful. So this is 0.5. The local return on the local currency is 4%, time period 1 year, and volatility of 12%. Okay, so there is a mismatch. I have to be careful here. The maturity was 8 months. So I've got to change this to 8 divided by 12. Okay, so let's have a look. Now, first of all, what we see using, if we were to implement the Black model and set it out using D1 and D2 as specified by the Black model, interestingly, although we're using slightly different formulae, we're getting the same results. So for the parameter values I've set out here, although different to what we have here, well, S and F are different, we get same D1, same D2 for both the Black Scholes model and the Black 1976 model. Okay, so and we can, the workings here are a bit different, but we can see the basic formal input, and when we apply this formula we find D1 corresponds to this value here, D2 corresponds to the value we have here, and then the value, we just have the value of the call here, and working it out manually we get the same result, and using VBA, right, we get the same results for the put and for the call. Okay, so what this demonstrates is that the Black Scholes model 1973 and the Black model 1976 are in fact just variants, and we're using basically the same set of theories, same type of assumptions. The principal difference is we work with the Black model, we don't use the spot as a parameter input, it's the futures price. But the futures price and the spot actually have a relationship, and that's defined in terms of this no arbitrage relationship, where the futures price is equal to the spot and then compounded forward with this exponential, and we have R, the risk-free rate in the local currency, minus the risk-free rate in the foreign currency times T. This relationship is a no arbitrage relationship. It also might be viewed as a kind of interest rate parity relationship, that the interest rates differentials into jurisdictions can be explained largely by differentials between the spot and future. So if a currency is depreciating, you might demand a higher local return, or if a currency is depreciating, you're willing to accept a lower return in a foreign currency because over time you expect the foreign currency to appreciate. Okay, so these type of relationships are well established in international finance, and we can see the logic here. Okay, but once we use take these as our base values and then generate the futures value using the no arbitrage relationship, we find D1, D2 are the same, and the value for the put and the value for the call are the same, regardless of which model I use, whether it's Black Scholes or Black 1973.